Thank you, Kelly. So as you can see here, you have a survey. You're a statistician, you ran a survey, and you found that, hey, on average, it takes 1.5 years for people to buy a new cell phone, all right? The standard deviation is 0.25 year, and then your job, your goal is to find the probability that the user will keep the phone for less than 1 year before buying a new one. Okay. We have some indication that this distribution is a normal distribution because it says the lengths of time people keep their phones are normally distributed. Okay, so how do we find the probability? Let's take a look at our board. Let's look at our calculator here. So as I mentioned before, it doesn't matter if you use your X or your Z, but for the sake of confidentiality of your data. So X, Z. I need to write them side by side so you see what's going on. Then you have X, then you have Z. So remember that here it says find the probability that X is less than 1. Remember that we calculated Z to be -2 or equivalent. You want to know what's the probability that Z is less than -2. The same calculation for X for Z. In this case, we're going to go to second vars, find the normal. CDF, the lower limit, as usual, the upper limit, as usual, mean, and the standard deviation. Okay, since it's less than, and as you remember, the graph says, hey, it is less than. When you have a graph with less than, it means that you're looking at the less than area here. So it's less than a value, either X or Z. This is your upper limit, and this guy is your lower limit. Okay, in this case, here we have less than 1. So our upper limit is 1, and our lower limit is going to be a very small number, like -10. The mean, remember from the question, the mean was 1.5, all right? So 1.5, and the standard deviation is 0.25. And now you want to use our calculator. Okay, show me how to use my calculator. Turn on your calculator, second vars, normal CDF, cumulative density function, enter. If it's already written, this form, do not change it, or if you feel comfortable using a negative number, remember that the negative sign is here in front of the number. This is subtraction. So the functionality that you're going to use for a negative number is this, -10, -100, and a small number. And the upper limit, as we mentioned, is 1. Mean of the data is 1.5, and the standard deviation is 0.25. So let's do that, see what is the probability. Okay, guys, the probability is 0.0228 if you want to round it this way, or you can just say that is 2.28%. So this probability is approximately 2.28%. Again, using X calculating the probability. If the data is not confidential, use the normal CDF, your lower limit and upper limit, mean of the actual data, standard deviation of the actual data, non-confidential. But if it is confidential, we converted that x equals to 1, converted that into z, which is -2. Now, for confidential data, if we do the process, it is second bars, normal CDF, very good. The lower limit, upper limit. If you're using TI-83, you're just going to use parentheses, lower limit, comma, upper limit. Just enter the numbers with comma separated, the mean, comma, standard deviation, close the parenthesis, and do the calculation. It's going to be the same. Upper limit, mean, standard deviation. We just showed that the mean and standard deviation for a standard normal distribution is 0 and 1. The lower limit, the upper limit is -2. The lower limit, just use a very small number, which is smaller than -2. It's going to be, for example, -10, -100. So second Mars, normal CDF, the lower limit, let's leave it as -10. The upper limit is -2. The mean is 0, standard deviation is 1, and let's do the calculation. Very good. As you can see, we got the same probability, 0.0228. So the probability is about 2.28%. As you can see, the area, this small area is about, if we just move this a little bit here, it's going to be roughly around here, which is 2.28%. So the probability that cell phone users will keep their phone for less than 1 year before buying a new one is about 2.28%. Now, suppose we are interested in knowing what is the probability that they keep their phone for more than 2 years. So far, we calculated that for less than 1 year. Just showed you how to use that. Now I want to know what is the probability that they keep their phone for more than. The keyword is more than. And I say, hey, the data are not confidential, are confidential. You are allowed to use them. It means that you are allowed to use X values. They are non-confidential. So let's take a look at this. More than 2 years. What is the probability that X is more than 2 years? So it says more than. What's the graph like? And we're talking about the graph of larger than. It means that it is on the right-hand side of your X value. This is just a general graph. This is just a general graph. I want to know, what is this probability? What is this area? This area is your probability area. What is this area? What is the probability? And it is larger than. So take a look at this. It means that my lower limit is going to be here, and my upper limit is far on the right-hand side. So take a look at this. My lower limit, and this guy is my upper limit. Where is that? I don't know. The graph keeps going. Remember that the graph never touches this horizontal axis. It just keeps going. It's going to be very small, but it keeps going. All right. Very good. So, second, Mars, normal CDF, lower limit, upper limit, mean, and the standard deviation. Okay, so what is my lower limit here? Remember that it says larger than 2, like 3, like 4, like 5, so my lower limit is 2. What about my upper limit? Use a large number, positive large number like 10. So lower limit is 2, upper limit on the right-hand side of 2, you get positive numbers, mean the same as the mean of the data, and standard deviation the same as the standard deviation of the data that we had. So let's take a look at a calculator. So let's turn on the calculator. Second bars, go to normal CDF, lower limit is 2, upper limit is positive 10, and mean is 1.5, and standard deviation is 0.25. Let's do the calculation. And as you can see, it is 2.28%. So 2.28%. The probability that users keep their phone more than 2 years is also small, 2.28%. Very good. Another question. What is the probability that they keep their phone between 1 to 2 years? What is this probability? How do we calculate the probability in between 2 numbers? Thank you, Juliet. Very good. So what do we have here? Thank you, Beth. It says in between. Hey, now my graph has its lower limit and also its upper limit. Both of them are mentioned in the question. I have both of them. So in general form, in between is going to be the area in between 2 numbers. So the lower limit is going to be the smaller number and the upper limit is going to be the larger number. So this is my lower limit, and I have my upper limit. Very good. So let's use our calculator. This is what we're doing. We're going to second, we're going to bars, we're going to normal CDF because we have a normal distribution, and we want to know what's the cumulative density function, the area below the graph. So now we want to know what is the lower limit, what is the upper limit. You need to identify all of these. The mean and the standard deviation. Guys, again, if the question doesn't mention anything about confidentiality of the data, you are allowed to use your X values. You do not have to make any changes. You don't have to convert them into Z. Absolutely fine to use your X value. So my lower limit is 1, and my upper limit is 2. So I have 1, I have 2. Lower limit, smaller number, upper limit, larger number. Lower limit, upper limit. Well, what's the mean? The mean as the data, 1.5. What are the standard deviation? 0.25. Okay, calculator comes to our help. Second bars, normal CDF, lower limit is 1, upper limit is 2, mean is 1.5, standard deviation is 0.25, and paste. Well, I have 95.45%. Approximately, it is 95.45%. The probability, what's the meaning of that? It means that the probability that I randomly select a user and that user keep the phone between 1 to 2 years is 95.45%. That's the probability. So if I randomly select a person, the probability that person keeps the phone between 1 to 2 years is 95.45%. That's the meaning of that. That's the interpretation. Thank you, Abby. So, as you can see, we have a survey. You're the statistician. You ran a survey. A shopper spends an average. Well, we have a keyword, everybody. Average of 45 minutes, and another keyword with the standard deviation of 12 minutes in the store. Well, the length of the time spent in the store, normally distributed, okay, they're represented by X values, and it doesn't mention anything about confidentiality of the data or not. So we're going to assume that the data are publicly accessible. Question says, find the probability that shopper will be in the store between 24 to 54 minutes. What is the probability that they spend more than 39 minutes in store? Let's take a look at our board. So here we have the following. So this is our example. Our example says, I have the following case. We want to know what is the probability that our X is bounded between 24 minutes to 54 minutes. Again, since it doesn't mention anything about confidentiality of the pictures, leave your X as it is and use your calculator using normal CDF for X. So remember that it's in between. It means that my lower limit and upper limit are already given to me. Lower limit, and I have my upper limit. Well, okay, so I need to use my calculator, normal CDF, second bars, normal CDF. Again, if you're using TI-83, just use parentheses, your lower limit, your upper limit, and the mean, which is given to us as, let's see, the mean is 45 minutes, and the standard deviation is 12. Or if you're using TI-84 and upper, or your emulator, the lower limit is 24. The upper limit is 54, mean is 45 minutes, and the standard deviation is 12 minutes, okay? So let's use our calculator. The second Mars, normal CDF. Well, I have 24. Well, the next number is 54, and then we have 45, and then we have, let's see, standard deviation, which is 12. Cool, all is done. 73.33%. 73.33% approximately. So what's the meaning of that? It means that if I randomly select a shopper and that shopper spends between 24 to 54 minutes in the store, is 73.33%. Okay, the second one says, hey, now what is the probability that that random person spent more than 39 minutes in the store? More than, it means that your lower limit is given. More than, your lower limit is given. This is your lower limit. Upper limit, it must be a positive number, a large positive number. Why is that? Because the graph continues. So second was normal CDF, and then If you're using TI-83, just use your lower limit, which is 39. Upper limit, use a large positive number, like 100, like 1,000, comma, mean is 45 minutes, and standard deviation is 12. If you're using TI-84 for your emulator, the lower limit is 39. The upper limit is a large positive number like 100, 1,000. Mean is 45 minutes with standard deviation 12 minutes. Very good. So let's do the calculation. Second bars, normal CDF 39, 100, mean is 45, standard deviation is 12, and paste to the calculation for me. It's 69.15%. 69.15%. That's the probability that you randomly select the person and that person spends more than 39 minutes in the store. So the second part of the question says, well, how many shoppers would you expect to be in the store? How many shoppers? Okay, I have the probability. Now I want to know how many shoppers. Well, okay, there is a very simple calculation. How many people are in the store? The same as for this guy. How many people are in the store? What are we going to do? Well, this calculation is just a basic calculation. What are you going to do? Remember that the question says, suppose you have 200 shoppers enter the store, okay? What is the number of people who spend between 24 to 54 minutes in the store? We have the probability. We have that area. We just need to do the multiplication. 200 people times 73.33% or just 0.7333. The same as here. If you assume 200 people entered in the store, how many people spent more than 39 minutes? We have the probability. It is 0.6915. Very good. So if you multiply these two numbers together, you're going to get about 147 people in the store. Okay, so it means that in the store you have 147 customers who spend between 24 to 54 minutes. What about the second one? If I multiply 200 by 0.6915, how many people you have? Do the calculation and give me the number. So we get about 139 customers or people in the store who are spending more than 39 minutes. So they can use this information when they are constructing a new store. They use this information to make the capacity of the store to be as accurate as it is. Based on the data that they have, they make predictions for the new construction or the new store. That's why you see some stores are smaller than the other ones, because based on the past data, the number of people who spend time in the store might be as small as 147 or might be as large as 1,000. Very good. So remember that we said that suppose x represents a continuous random variable, and suppose you want to convert that into a confidential data type, z value, z score.